Class 8 Subject Chemistry Chapter 4 Materials, Metals and Nonmetals Module 2 Objectives. At the end of this session, you will be able to know the reaction with oxygen of metals and nonmetals, reaction with water of metals and nonmetals, reaction with acids of metals and nonmetals, and finally reaction with bases of metals and nonmetals. Chemical properties of metals and nonmetals. Reaction with oxygen. You know that iron is a metal. You have learned that when iron reacts with oxygen to form a different substance called rust, it is a chemical reaction. What is rust? It's iron oxide and also called as hydrated ferric oxide. So we can say that iron reacts with oxygen to form iron oxide. Fe plus O2 plus H2O gives Fe2O3. This is the equation for the reaction. Rust is hydrated ferric oxide. Its formula is Fe2O3.XH2O. You also know that when we burn a magnesium ribbon, it burns with a bright flame to form magnesium oxide. That is a chemical change too. Here is the equation for the reaction. Mg plus O2 gives MgO. You can also write the word equation for the reaction. Magnesium plus oxygen gives magnesium oxide. Copper also reacts with oxygen. A copper vessel kept in moist air for a long time gets a green coating. What is the green substance? It is a mixture of copper hydroxide and copper carbonate. The equation for the reaction is 2Cu plus H2O plus CO2 plus O2 gives CuOH twice plus CuCO3. What is the nature of these metal oxides? Are they acidic or alkaline? We put these oxides in water and then we check if the solution formed is acidic or alkaline. Now, how do we do that? Do you remember something called litmus? You have studied it in 7th science in acids, bases and salts. Well, that litmus paper is used to check if something is acidic or alkaline. If blue litmus turns red, then the solution is acidic. If red litmus turns blue, then the solution is alkaline. When you put red litmus paper in the mixture of oxides in water, it turns blue, indicating that these solutions are alkaline. So we conclude that oxides of metal are alkaline in nature. How do nonmetals react with oxygen? We can find out by burning a non-metal like sulfur. Take some sulfur powder in a deflagrating spoon. A deflagrating spoon is a spoon with a long vertical handle. When you heat sulfur, it burns. Quickly put the spoon in a gas jar and cover it with a lid to ensure that the gas produced does not escape. After some time, remove the spoon from the jar and add some water to the jar and shake it well. That way the gas dissolves in the water. Then check it with litmus paper. You will see that the solution turned blue litmus red, so it is acidic. Oxides of nonmetals are generally acidic. What happened when you burned the sulfur? It formed sulfur dioxide. The equation is S plus O2 gives SO2, and when we mixed it with water, it formed sulfurous acid. The equation is SO2 plus H2O gives H2SO3. Let's see how it is done. Reaction with water. Some metals react very strongly and quickly with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. Let's see the reaction. When a metal reacts with water, then the products formed are metal hydroxide and hydrogen gas. Metal plus hydrogen gives metal hydroxide plus hydrogen. For example, 2Na plus 2H2O gives 2NaOH plus H2 plus heat. The word equation for the reaction is sodium plus water gives sodium hydroxide plus hydrogen plus heat. However, all metals do not react this way. Iron reacts very slowly with water. What about nonmetals? Most nonmetals do not react with water, though they may be very reactive in air. Such nonmetals are stored in water, for example, but some do react very vigorously with air. For example, phosphorus catches fire in air, so it is stored under water. Reaction with acids. When metals react with acids, they usually release hydrogen as a result of the reaction. Let's see that happen. Take 4 test tubes, put a magnesium ribbon in one, a small piece of aluminium in the second one, iron filings in the third, and a small copper wire in the fourth. Using a dropper, add 5 ml of dilute hydrochloric acid to each of the test tubes. If you see no reaction, warm the test tube gently, as heating always speeds up any reaction. Remember to be very careful in this experiment. Now take a burning matchstick near the mouths of each of the test tubes. What happened? You hear a slight pop on the first 3 test tubes and not on the fourth one with copper. The pop sound was because hydrogen was released in the reactions in the first 3 test tubes. Hydrogen is a highly combustible gas and gives a pop sound when heated and combines with oxygen in the air to form water. Chemical equations of the reactions are: magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen. Mg plus HCl gives MgCl2 plus H2. Aluminium reacts with dilute hydrochloric acid to form aluminium chloride and hydrogen. The equation for the reaction is 2Al plus 6HCl gives 2AlCl3 plus 3H2. Iron reacts with dilute hydrochloric acid to form ferrous chloride and hydrogen. The equation for the reaction is Fe plus 2HCl gives FeCl2 plus H2. Copper does not react with hydrochloric acid at all. Copper, however, reacts with concentrated sulfuric acid to form copper sulfate along with water and sulfur dioxide gas. Here is the equation. Cu plus 2H2SO4 gives CuSO4 plus SO2 plus 2H2O. What happens when you do the same with nonmetals? If you try the same experiment with charcoal powder and sulfur powder, you will see that there is no reaction at all. So nonmetals do not react with acids. Reaction with bases. What happens when metals react with bases or hydroxides? Alkalis or bases are hydroxides of metals itself. For example, sodium hydroxide. When you put a piece of aluminium in a sodium hydroxide solution, a reaction occurs. Again, when you hold a burning matchstick to the mouth of the test tube, you hear a pop sound. That tells you that the gas released is hydrogen. So when bases react with most metals, hydrogen gas is released. The reaction of bases with non-metals are quite complex. You will study them when you are older.